Welcome to Khetz tutorials, and in this video I'll be doing question 57 from 1.5 exercises in James Stewart calculus. So the first question says find the domain of f of x equals to ln of e to the power x minus 3. Alright, so let's find the domain of that. We know that this argument of ln has to be greater than 0. So that is the condition which we're going to force here. So we want this to be greater than 0 for this to exist. And we'll now have e to the power x greater than 3. You can find the ln of both sides. So if we find the ln of that and the ln of that, this now comes down and we have x greater than ln 3. And that is our domain basically. So that's the first question. In the second question, we're asked to find the inverse and its domain. So to find the inverse, we are going to either swap the x and y from the beginning or delay it for a bit. That's up to you. So if you want to swap it at this point, you can go ahead. So you can swap x and y here. So this would be x in place of y, and this would be y in place of x. All right. Then you can find, or you can raise each side as a power of e. So you can do this now. And on this side, you just have e to the power x. Then on this side, this allows you to take this out or take it downwards. And you now have this. Let's swap these sides. I just want to have this on my left because that's how we usually have it. We usually have the y on this side. But as you can see, I haven't really changed anything. Each side still has the parts that it initially had, just that I swapped the sides. Okay. Then I'm going to isolate the y, and that requires me to move this to the right hand side, so now b plus. Then I'm going to find the ln of both sides, and here that allows me to bring the y down. On this side I just have ln of e to the power x plus 3, and that will be our inverse. So that is our f inverse over there. And now we also asked to find its domain. All right, and let's have a look at what the range of the original would be. So remember that when you move from an original function to its inverse, then the original range becomes the domain of the inverse and vice versa. So from f of x to its inverse, this one's range becomes the inverse's domain and vice versa. So it works in both directions. So let's figure out what the range was here. So this just has to be greater than 0, just as we saw, and we don't expect it to be negative because we get an error. And since it will always be greater than 0, this part here will always be greater than 0, then that means that we can start thinking about it as from, well, there are a bunch of values in between, but we can start here, which is when we have a 1. So this is the first value that we can think of, which is greater than 0. So if you substitute ln of 3, which we calculated in the previous question, up here, that would be ln of 3 minus 3, and we don't necessarily want that. So we said it was going to be greater than ln 3. So this will basically give us an answer which is greater than 0. So perhaps 0,1 or something like that. And those values have the potential of being negative. So from that point, so based on that information, we can start to figure out what the range of this thing would be. So it does have a few negative values, and 0,1 is even on the high side of those values. And if you try to substitute different values here, that will give you the range of your original function. which would then be the domain of our new function. And through a few substitutions, or just visualizing what that was supposed to look like, then you'd see that it kind of looks like your normal len, because it is a len, and that has a range from the negative values down here all the way to positive values up there. And that would be the domain of this inverse function. So the range that you would have there would now be the domain of this inverse function that we just found over here.